A ball is thrown in such a way that the initial vertical and horizontal component of the velocity are 40 and 20 meter per second. So let's analyze the situation. So we have a ball. We are throwing in such a way that the horizontal component is 20 and vertical component is 40. So this is much bigger. So we need to estimate the total time of flight. That is basically if it goes in this way. Okay, all this you guys know. We need to figure out the total time and the distance the ball is reached from the starting point. Okay, but we don't have angle, we don't have quite a few things. How do we go on doing this? We have to make use of this. You know, two vectors, two components of a vector. You need to find the resultant, that's it. Basically, it would look something like this. That would be your resultant, as simple as that. So basically, we need to figure out time of flight and you have range. Actually, them resolving it, actually we don't need to figure out the resulting vector. Right? Let me talk about y component. So y component deals with your initial velocity along the y is 40 meter per second. Then you have the maximum or velocity at highest point, the maximum height actually. Okay, maximum height is what we call it as, is 0 meter per second, right? At the topmost point over here, it will have 0 meter per second. This we have seen actually over here. This point basically. At this point, I'm just looking at this motion. At this point, the velocity is 0 and the h is h max. That's the maximum height. Y is h max. And we can call this t as t by 2. Right? So we have all of this information. So let's figure out t. So what can we use? V is equal to u plus at. And also acceleration due to gravity is g. And we can consider up and right as positive. So we can make use of v is equal to u plus at. So this is 0, this is 40, this is minus 10, and this is capital T by 2. So this will be 4 and 8. So this is 8 seconds. That's the total time of journey. 5 and 8. Yeah. That's it. Now I take x component. So we know the time of journey is 8 seconds. And you know the initial velocity along the x-axis is how much? 20 meter per second. With this two information, you have your distance is equal to velocity into time. So 160 meters. Or the range, if you guys want to call it as a range. Therefore, range is equal to 160 meters. That's it. A very simple question actually.